So we're going to do section 6.2. This is going to be a lot like 6.1. The difference is in 6.1, our population standard deviation is known. And so they gave us sigma. But this time, for 6.2, the confidence interval is going to be unknown. So they do not give us the population standard deviation. Therefore, we're going to have to use what's called a t-distribution. Otherwise, most of what we're going to do is going to be the same. It's just that in StatCrunch, instead of going to ZStat, we're going to have to go to TStat. And so the t-distribution is still bell-shaped and symmetric about the mean, meaning on the left-hand side and the right-hand side. The mean, median, mode are still in the middle and equal to 0. But for a t-distribution, the tails are going to be what we call a little thicker, and I'll show you that in just a minute. With the t-distribution, we're going to need what we call degrees of freedom. That's right here. And with the degrees of freedom, that's the number of free choices we have left after a sample statistic, like the sample mean, is calculated. So for us in this class, our degrees of freedom is going to be equal to n minus 1, and that is on your resource sheet, excuse me. And so we're going to take the sample size and subtract 1 from that. So what happens with that, you can see these curves down here. If you look at the curve, the black curve here, the degrees of freedom are 2. And notice how much space, that's what they mean when they say thicker. See how much space is between the curve itself and our number line. Whereas the degrees of freedom get larger, so 5, that is the gray graph here, and see how it's getting closer to the number line, and so therefore closer to a standard normal curve. The teal here curve is our standard normal curve. So remember, that actually approaches the number line. It's very close, but never actually touches. And so as we get larger sample sizes, the t-distribution is very close to the standard normal distribution. So that would be for 30 or more. Okay, so let's take a look at a problem. This is showing the t-table that's in MyMathLab. We're actually going to use StatCrunch. We're not going to worry about these tables. But what happens is they want the critical value, but this time they're calling the critical value T of C. And that's because we do not know the population standard deviation. So they're asking for the critical value T of C if C is equal to 95%, right? That's my confidence level. And they want the sample size to be 15. So N is equal to 15. That means since our degrees of freedom is N minus 1, that means that our degrees of freedom are going to be 14, right? 15 minus 1. We're still looking at the area under the curve, and we're still looking at the between. So what we're going to do is we want the area between to be this 0.95. That's our confidence level. We are not going to worry about this table. We're going to go to the next page. But I just wanted you to see that we want the area between. And so again, when we find the answer, our critical values are going to be symmetric. They're going to be the same number, but one side's going to be negative, the other side's going to be positive. So let's go ahead and look at the in StatCrunch. So this is the same problem. We're going to go to Stat and then Calculators, but this time we're going to come down to T. Okay, so we're going to look at the T calculator because we need our critical values. So when we come over here, we are going to put in our degrees of freedom. Remember, that was 14 because that was the sample size -1. We're looking for the critical value. So and of course we hit between. So we're looking for this value and this value, but we're going to put in the 0.95 because that's what they told us they wanted the area between to be. As soon as I do that, I get negative 2.14 on the left-hand side, and then I get positive 2.14 on the right-hand side. For this problem, because they just want the critical value, they just want the 2.14. They know that you know that we're also going to have the symmetric number on the left-hand side and have negative 2.14. Okay, let's try another one. On your resource sheet, you're going to have your formulas. You'll see they look a lot like the formulas we had in 6.1, except in 6.1, we had the population standard deviation and we use Z of C. For this section, because we do not have the population standard deviation, we're going to use T of C, we're going to use a T distribution, and we're going to use S, which is the sample standard deviation. Of course, we still need our sample size. And so the other part is going to work again the same way. When we see that we don't have the population standard deviation, we still need to know that the population is normally distributed or that n is greater than or equal to 30. So that's an or. They can tell us one or the other, and that means we can use the t distribution. We have to know our degrees of freedom, which is going to be n minus 1. And then our margin of error is going to work the same way, that it's going to be the sample mean plus or minus e, the margin of error. But again, StatCrunch is going to do that for us. So we are going to have to read very carefully because we need to see if we have the population standard deviation or the sample standard deviation. And you know, come the quiz and the test, they're going to mix those up. So we've randomly selected 16 coffee shops. That means that our n is going to equal 16. And then that also means that our degrees of freedom would equal 15, right? One less, 16 minus 1. Okay, then we're going to measure the temperature of the coffee sold at each of these coffee shops. So first they tell me that the sample mean temperature is 162 degrees, 162 degrees. So that's my sample mean, is 162, with a sample standard deviation of 10 degrees. And so that's my sample standard deviation. As soon as I see that I have a sample standard deviation, I know that I'm going to need to use t-stat in StatCrunch. All right, and then finally, we're going to construct a 95% confidence interval, and so C is going to be 0.95. Let's see, what else do they tell me? We know that 16 is not greater than or equal to 30, but luckily they told me at the end to assume that the temperatures are approximately normally distributed. So since they told me that, I still can use the t-stats. All right, so let's look, now that we know all of that, let's look at StatCrunch. All right, we're going to go into StatCrunch. We're going to go down here to t-stat. So we use calculator t if we're looking for the critical values. If we want the confidence interval, we're going to come down here to t-stat, one sample with summary. And then we're going to put in what we know. So we know the sample mean is 162. The sample standard deviation is 10. The sample size is 16. So this one's different. It didn't ask for degrees of freedom. It asked for the sample size, and so that's 16. Then we're going to come down here and click confidence interval, and we want our confidence level to be 95%. So we're going to put 0.95 into that. And then we hit compute, and ta-da, it's going to do the work for us. Our lower level is here, it's going to be 156.7, so that's right here. Our upper limit is here, that's 167.3. Okay, so if I draw on my number line, what's going to happen is I'm going to use every single number between 156.7 and 167.3. Okay, so my confidence interval is every single number inside those parentheses, excuse me. Okay. This is the same problem if you don't use StatCrunch. If you want to do it by hand, but we want to use StatCrunch, right? We want StatCrunch. It's much easier. What they did was they found the margin of error. They took the sample mean of 162, they subtracted the margin of error, and they added the margin of error, and they get the same numbers as us. And so they get the same confidence interval as well. So we are 95% confident that the population mean is going to be somewhere between 156.7 and 167.3. Okay, let's look at another problem. So you randomly select 36 cars. All right, we randomly select 36 cars. That is my N, that's my sample size, of the same model that were sold at a car dealership, and we determine the number of days each car sat on the dealership's lot before it was sold. Okay, the sample mean is 9.75 days, so I'm going to write that right there, sample mean. The sample standard deviation is 2.39. Okay, so since it's sample standard deviation and they didn't give me the population standard deviation, we know that we need to use t-stat, not z-stat. And then they want me to construct a 99% confidence interval. So my confidence level is going to be 0.99. So we're going to construct a 99% confidence interval for the population mean number of days the car model sits on the dealership's lot. So I've got the answer here, but I did it in StatCrunch. So let's take a look at the next page. All right, so I'm going to go to Stat, come down here to t-stat, go over to one sample, and finally with summary. Okay, then I'm going to put my sample mean in, that's 9.75, my sample standard deviation, and my sample size of 36. At that point, I'm going to click confidence interval and put the 0.99 in there. So now when I hit compute, it's going to give me a lower limit of 8.7 and an upper limit of 10.8. So at this point, I am 99% confident that the population mean is going to be somewhere between 8.7 and 10.8. All right, so let's take a look at a little flowchart. Now that last problem I did not, I don't think I said, the sample size was greater than 30, it was 36. And so we were good to try to, using the t-distribution. It didn't say anything about being normally distributed, but the sample size was big enough. So if it does not say that the population is normally distributed, or if the sample size is not greater than or equal to 30, we would have to use something else. We cannot use the z-stat or the t-stat. We can't use the normal distribution or the t-distribution. Now, if one or the other of those is true, then we're going to come to the next box, and we want to know whether the population standard deviation is known or not. If it is known, then we're going to come down here, and we are going to use the normal distribution. And so that means that we're going to use z-stat. Or if you want to do it by hand, you have your margin of error formula here. If the population standard deviation is not known, then we're going to come down to this box, and we are going to use t-stat. And that's because we don't know the population standard deviation, but we do know the sample. And so then we're going to have our formula for the margin of error, and we also are going to have to use the degrees of freedom. Okay, so let's set up a few problems here. This one, you randomly select 25 newly constructed homes. So that means that n is equal to 25. It's not over 30, and so we're going to have to look a little further in our problem and see if it says something about being normally distributed, but it does. It says right here, assuming construction costs are normally distributed. So as soon as we see that, we know that we can use either the standard normal distribution with z-stat or the t-distribution with t-stat. Okay, then they give me the sample mean is $181,000, so that's going to go here. And they give me the population standard deviation of 28,000. So since it's the population, that means that we can use z-stat, right? We can use the regular normal distribution. And so we do have to adjust, depending on what we're doing, we do have to adjust the standard deviation, and we're going to take the population standard deviation of sigma on top, and on the bottom, the square root of the sample size. All right, let's look at a couple of homework problems. So this one is asking for the critical value. As soon as you see that it's asking for the critical value, that means you're going to want to use either calculator normal or calculator T, and it's going to depend on what information they give us. Now, because they asked for T of C, I'm going to use calculator T. If they had asked for Z of C, I would use calculator normal. Okay, so let's see what they gave me. They gave me my confidence level of 0.80. They gave me the sample size of 6. That means my degrees of freedom are 6 minus 1 or 5. Okay, so remember, I always want between with a critical value. And so I'm going to hit, once I get to calculator T, I'm going to hit between so that I can see the area here. I'm going to put in my degrees of freedom of 5, and my C goes over here. My confidence level of 0.80 comes on this box. Then when I hit compute, the computer is going to give me negative 1.48 and positive 1.48. So just because they only want the critical value, I'm going to go ahead and put the positive number, the 1.48. They know that we know that that also includes the negative 1.48. All right, this problem is asking me for the margin of error. It gave me C, S, and N. So as soon as I see that I have S and I do not have sigma, I know I'm going to have to mess with T. And so I'm going to grab my formula here that is for the margin of error for the T distribution. But before I can do that, I have to use calculator T because I have to find T of 0.99, right? We have Z of 0.99 on our resource sheet, but not T. So we're going to go into calculator T. We want to hit between. We want the area between the curve here. And so when we do that with the area in between, we're going to put our degrees of freedom. Well, our sample size was 27. Therefore, our degrees of freedom is 26. And we're going to put the 0.99 on this side, the confidence level. As soon as we do that, we are going to hit compute, and we're going to get our critical value of 2.78. So that's how I got the 2.78 right here, right from the calculator T. Okay, so T of C, we need to go into calculator T. Z of C, we're going to go into calculator normal. And then we're going to fill in the rest of the formula. S is 3.6. They gave that to us up here. And then on the bottom is the square root of the sample size. So that's the square root of 27. Once you pop that into your calculator here, you'll see that you get 1.93 as the answer. So this is my margin of error. So at that point, if they asked me for the confidence interval, I could do that, although they'd have to give me the mean. All right, here's the last problem we're going to look at today. They gave me a confidence interval. They gave me that the lower end is 13.2, the upper end is 21.0. And they want to know both the margin of error and the sample mean. So we have a couple choices here. I like to find the mean first. So what I do is I find the average, right? I take the lower limit of 13.2, I add that to the upper of 21.0, and then I divide by 2. And so this value, this 17.1, is going to be my sample mean, and that is going to be smack dab in the middle of my confidence interval. Now at that point, I have a couple of choices. I can just subtract. I mean, that's what I would do. You could just subtract the 21.0 minus the 17.1, that's supposed to be minus, and that's going to give you your margin of error, because remember the margin of error is on each side. We added the margin of error on the right-hand side and we subtracted it on the left-hand side. So you also could find the distance. That's what I did here, and I cut it in half. But it's easier, I think, to just find the mean and then find the difference between the mean and one of the endpoints. So they're going to want both of these. They're going to want the margin of error is the 3.9, and the sample mean is 17.1.